Hi, I'm Bram Desmet with Flanders Scientific, and in this video, I want to provide you with an overview of the latest firmware release for our XMP and XMP Series of monitors. This build brings several incredible new capabilities to these displays, so let's dive right in and see what's new. First up, we've made extensive updates to Quad View mode, starting with an update to the name for this function in the function menu. Previously, this was called 3G HDN x 4, and this was because Quad View mode only supported 4 x 3G or 1.5G signals. We've now renamed this to simply Quad View mode in this function menu, both to make it easier to find and understand, and because we're happy to share that Quad View mode now supports not just 3G and 1.5G signals, but 12G and 6G signals as well. As before, signals do not require genlock for Quad View mode, but they must all be the same frame rate. We've had questions about this in the past, so just a quick explanation here as to why the signals must be the same frame rate for Quad View mode. As a reference monitor, we always set the panel's refresh rate based on the incoming signal format to ensure proper reference playback of signals. A monitor that does not do this, and instead always refreshes at one fixed rate instead, will interpolate and remap signals, which can lead to cadence or frame rate artifacts that prevent the monitor from showing you the signal as it really is, in addition to adding processing delay for this remapping process. While we can easily set a panel to match any given frame rate, what we cannot do is refresh different quadrants of the panel at different rates. With this in mind, to ensure that we can continue to always refresh at a reference interval of the incoming signal, and can do so with minimal latency, the signals must be the same frame rate when using Quad View mode. Another update to Quad View mode is that you now no longer need to have 4 active signals going to the monitor to enter this viewing mode. Previously, empty inputs were not supported, but in this latest build, you can now view 2, 3, or 4 signals on screen at the same time. Any missing signals will simply be shown as a black quadrant when using Quad View mode. Next up, you'll find some very significant updates to the color management menus on the monitor. These changes were made to support an incredible new capability that allows you to set individual color configurations per input, even for simultaneous use in Quad View mode. That's right, you can now use Quad View mode and easily set a completely independent color configuration per input, allowing you to see independent gamuts, EOTFs, white points, single ranges, and luminance settings per quadrant on screen at the same time. While very powerful, this obviously leads to some more complexity in menu layout and options. But for those that don't need these new capabilities, don't worry. We've made sure to add a straightforward way to allow your monitor to work as it has always worked in the past, with one simple global configuration that can apply universally to all inputs as it always has. So let's see how this works and how the color menu has been updated. The first thing you'll notice is that the color menu has now been split into 2 color menus called Color Global and Color Input. The Color Global menu contains color management related settings and features that always apply to the monitor across all inputs. Here you'll find your toggles for starting Gaia Color AutoCal, setting the color system to Gaia Color or third party, and gain bias settings, which always apply globally to all inputs. As you can see, even with all the updates that we are about to cover, FSI remains committed to an open calibration architecture, and third-party calibration remains supported for those who want it. Just note that when in the third-party color system mode, only the range and lume selections from the color input menu, which we will take a look at in a minute, will remain similarly adjustable as they are in Gaia color system mode. Gamut, EOTF, and temperature will all be deactivated and will not be selectable in third-party color system mode, as these parameters are all instead governed by the third-party user LUTs directly. When in third-party color system mode, you can still save a combination of 1D and 3D LUTs to 6 different memory slots, and we've renamed this for greater clarity to third-party CLUT, where the C stands for calibration. Also note that the individual input capabilities we're going to cover shortly will only work in the default Gaia color system mode. Third-party calibration LUTs are only supported for global application to all inputs. Unless you are specifically using third-party calibration, please leave color system set to Gaia color to enable the exciting new capabilities we are about to cover. Before delving into the color input menu, there's one more new menu item on the color global menu that we should cover, and that is the Gamut toggle. This new Gamut toggle governs the gamut mapping behavior of the monitor when targeting a color gamut larger than the monitor can achieve. You'll find two settings here: hue preservation and max saturation. Hue preservation is how the monitor has always behaved in the past, and this is the mode we typically recommend users utilize. So if you get confused by any of what follows or are unsure of what to use, we suggest you simply stick to hue preservation. This mode tracks the correct hue angles for any input code values relative to the selected operating color gamut, for example 2020, and simply hard clips when that is no longer possible. This mode prevents hue shifts at gamut clip, and we generally consider this the correct reference behavior for professional reference monitors. However, some calibration systems and some monitors employ a different approach that chooses to prioritize saturation preservation over hue preservation. When operating in 2020 mode, this means that input signal code values that exceed what the monitor can reproduce will see a hue shift towards monitor native gamut, and therefore more saturated colors, even though those saturated colors will no longer be tracking the operating gamut hue faithfully. We added this to give users an option because some third-party calibration systems prioritize hue preservation, while others prioritize saturation preservation, and similarly, some reference monitors behaved one way while others behaved the other way. While we do believe hue preservation is more appropriate, we've had a fair number of requests from users over the years to provide an option for prioritizing saturation, like these other systems sometimes do, to make it easier to induce similar behaviors between our monitors and monitors or calibration systems using this other approach. So the choice is now yours, and we've made it a simple menu switch that does not require recalibration. Simply select your desired setting and the monitor will do the rest. Note, this only applies to Gaia color-based color configurations. For third-party based calibration, this will be entirely governed by the calibration LUTs generated by those systems. So now let's take a look at the new color input menu. At the very top of this menu, you'll find a selection called Input Color Mode. When set to global, the monitor will continue to work largely as our monitors have always worked in the past, where the color configuration of the display is applied universally to all inputs. Whatever range, gamut, temperature, EOTF, and luminance selections are configured in the global input color config will apply universally on the display. For those of you looking to minimize complexity and use the monitors you have in the past, this is the easy, straightforward mode for you. One new feature you'll find while in Input Color Mode Global is the capability to quickly assign any of 16 different saved look DIT LUTs to any of the SDI inputs. Previously, you could only save 4 DIT look LUTs to the monitor's memory, and each look LUT was directly assigned to just one input. We made this much more powerful in this release, and you can now use the IP remote utility to save a total of 16 different LUTs to the monitor's non-volatile memory, and then each SDI input can be independently assigned one of the look LUTs directly from the color input menu. There are many potential uses for this feature. One example use case being needing to monitor 4 different cameras, each requiring a unique D-log LUT that you'd like to save directly to the display. You'll simply set the monitor to the appropriate viewing mode, for example Rec 709 at Gamma 2.4, and then you'll save and assign your various D-log LUTs to the display to normalize the various camera signals to the same display color space. Moreover, once your desired LUTs are assigned, you can use the Look DIT LUT function button to quickly turn all 4 DIT look LUTs on or off. Again, these are only accessible if you are in the global input color mode. You'll see that when we switch to the individual input color mode, these become grayed out and inaccessible. This is because the individual input color mode requires a lot of extra processing power and memory that becomes freed up when using a single global calibration configuration for the display instead. The individual input color mode is probably the most significant part of this new firmware update. When set to individual input, you can now configure completely independent color space selections per monitor input. This serves many potential purposes. For example, some users may simply want dedicated inputs for certain types of signals and monitoring setups, like perhaps setting up SDI1 for P3 PQ monitoring, SDI2 for Rec 2020 HLG monitoring, and SDI3 for Rec 709 Gamut 2.4 monitoring. The other incredibly significant thing you can do with this individual input color mode is utilize it in combination with quad view mode, so your monitor can be set up to display 4 different color configurations on screen simultaneously. As an example, you could use this to monitor HDR and SDR versions of a camera output on the same display at the same time. To set up the monitor for individual input color configuration, start by setting the input color mode to individual input. Next, scroll down to the Input Color Config menu item and change this from Global to SDI1. When you do this, you'll see that all of the menu items below the selected input will become individually configurable for just that input. You can set your desired signal range, gamut, white balance, EOTF, and luminance settings, and the selections will only apply to that one input. You can then change the input color config option to SDI2 and repeat the process to set up your desired configuration for SDI2. Repeat these steps for SDI3 and SDI4. One reminder here, for these individual input color configurations to apply, you must have input color mode set to individual input. If you have this set to global, then the global input color config will apply universally to all inputs instead. We've also updated the scopes, menus, and OSD status windows to run at a consistent SDR range luminance in all modes, ensuring they remain comfortably visible even when working in HDR. Menu brightness can still be adjusted from the OSD. Aside from these powerful new features, we've also addressed several bugs and general performance optimizations in this build. That being said, this was a massive code rewrite, so if you discover any new bugs, please let our team know so we can track those and address them in future builds. We have a lot more planned for the XMP and XMP Series units, and we hope you find these and future updates useful. Thank you.